Go. You transition, you go.
Great, good afternoon and welcome to our latest alumni lecture here at the School of Information and Library Science. I'm Gary Marcinini, the Dean of SILS, and I am thrilled today to welcome Sayan Chakraborty, who is an alum of our program here, also an alum of IBIBLIO, one of our very long-standing research and service projects, and Sayan has had a really interesting work experience since leaving SILS, and he's going to share some of those experiences, but also talk about the really exciting things that are going on to try to save our planet and the world, and with not just technology, but with good, solid thinking and management. So, Sayan, take it away.
Thank you, Gary. So first of all, I really appreciate this honor. Thank you, Dean Marcinini, and I'm also very pleased to have Professor Paul Jones here, with whom I worked years ago and managed to keep in touch, and welcome the rest of the team here, as well as online. I don't know if you guys can hear me clearly in the back or online. All good. So before I get started on the talk, I just wanted a little bit of a show of hands in terms of how many students here are, first of all, students, and if you are from the IS program, you can raise your hands. Not from IS. Okay. Who from IS? Rest are from LS or research. Professors? Yeah. Okay. So this talk is going to be a little bit different. Hopefully, it will give you some insights into what is going on in this interesting, crazy world. My plan is to, present my slides for maybe 30-40 minutes, and then we can go into Q&A. But before I actually start off with the actual presentation, you are thinking this talk will be about global temperature, global warming, global average surface temperature. Maybe you are thinking this talk will be about sea levels rising. Maybe you are thinking I'll talk about the sea ice. It's at its historic lows since forever. Maybe you are thinking I am going to talk about recent temperature trends, the warming planet. And because I am giving this talk here in the US, everything is in Fahrenheit. So my friends in the rest of the world, you can calculate it in Celsius yourself. Or maybe I'm going to talk about this biodiversity collapse, right? Everything is going to collapse. Actually, my talk is going to be about none of these. This talk is going to be about voting. Voting with your ballot. Sorry, actually it's supposed to be wallet. Okay. Voting with your personal dietary choices. We have heard a lot about this in the press. Stop eating this. Or as one of my friends in Europe says, why are we having avocados in Norway in the middle of the winter? So it's not about personal dietary choices. It's not about your voting with your ballot or wallet, but it is about voting with your talent and ingenuity. And this talk, especially for us, information professionals or students, is really important because it is up to us where we can leverage our talent. And I hope that this talk will give you some pointers on why you should vote with your talent and ingenuity to address some of the challenges facing humanity. with that said, there are many, 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 many challenges. But I don't want to boil the ocean, even though the oceans are warming. But I will talk about sustainability a little bit. So if you look on the screen, this is called a donut model. It's not sugary or sweet, or it will not change your diet, but it's still a donut model. No free coffee here either. So, but this donut model is a very interesting way of looking at all of our challenges, all of humanity's challenges. On the outside are the ecological or natural or the planetary challenges, from climate change to land conversion, freshwater issues. Some of these have been addressed. Fortunately, ozone layer depletion is far better right now than a few decades ago. So that's the outside circle. So it's about the planetary boundaries which we may be at a risk of overshooting, what our planet can sustain. The inside part of the donut talks about the social foundation, which is, I think, very important for us who are in between technology and humanities to really understand what are some of the social, think of it as the bottom of the Maslow's hierarchy of needs, or your physiological needs. A deficit in these would actually degrade our, our living standards, potentially is actually a cause of, poverty, disease, etc. So there is a nice Goldilocks zone in between, which is the safe zone for sustainability, the green zone for sustainability. So I want you guys to have this in the back of your mind when we are going through the rest of my talk. So when you see this donut economic model, you can actually plot countries on this, or regions, or cities on it. The city of Amsterdam, close to where I live, also has its own donut economic model. But I want to show you the one which was made recently for planet Earth. This is our situation right now. We have way past overshot what the planet can take on in terms of climate change, in terms of biodiversity loss, land conversion, and a whole host of other issues. But at the same time, globally, we are also falling short on some of our social foundational needs as well. So, a little bit of a dire message here, but where there are challenges, there are opportunities, and when you are down, there is always some hope. And the way this is addressed is, so looking at these kind of issues, say global challenges, the UN actually put down a list of sustainability goals. So what is the sustainability challenge, and what do we actually mean by sustainability, right? It's important for us to understand that sustainability is about actually meeting the needs and not the wants. And second, it is also future looking, so that you are able to meet the needs of future generations. And the UN calls out about 17 of these, and together, the UN says that this is important for prosperity for the people, planet, as well as partnerships. But this is a lot to take in, right? And as I said earlier, we can get lost. Out of the 17 goals, each of them are, each of the goals are fairly comprehensive, fairly detailed, very challenging, and I'm sure lots of grad students PhDs and postdocs can spend their lifetimes working on each one of them. So where do we even start? So my idea is to focus on energy. And why do we focus on energy? One of the reasons is that energy actually directly impacts 5 of these goals, and I've listed them out here. Affordable and clean energy, industry innovation. I'm not going to read through the list. You guys can read through the list. But all of these goals can be met if we enable a sustainable energy transition. And why do we even need that? The number one reason is when we look at what are these major global challenges, the energy sector actually is one of the largest emitters of greenhouse gases and contributor to climate change, which in turn actually disrupts energy, which in turn causes stress to infrastructure and risks to people. And every country on this planet, every society on this planet is affected. So, for me personally, I thought energy is one area to look at and to potentially make an impact. So what is the energy problem, right? If we have to solve the energy problem, how do we even define what is the scale of the problem? This is an interesting diagram. It's a Sankey chart diagram. The folks who are into visualization and UI and love these diagrams, you can go to the Lawrence Livermore National Lab website and download this. This is for the US. Similar ones are available for every major region in the world. But this is also a glimpse into the staggering scale of our energy-based economy. On the left you see, and don't look at the actual numbers. The numbers actually are not as important as the ratios are. But on the left you see all the energy sources. The top section are relatively cleaner, renewable energy sources, from solar down to geothermal, here, and in the bottom are the ones which are are going to be net emitters of greenhouse gases, natural gas, coal, biomass, and petroleum. So those are the sources on the left. In the center is what are some of the intermediate uses. So a pretty large chunk, as you can guess, in the US goes into electricity generation. And then there are similar uses for transportation, industrial, commercial, residential. And finally, you have the actual usable output. After you put the energy into the system, you have to get some work out of it. The usable output is all at the very end, the bottom, energy services. And rest of it is rejected. So to give you a rough idea, about 83% of them are sources with significant CO2 emissions. So if we have to solve the energy problem in terms of addressing climate change, we can either address at the source level, or we can address by bringing down the amount of loss and unusable energy, which is a staggering 67%. Over 2/3 of the energy we actually generate goes waste. And in our experience, by talking to a number of experts, this is actually one of the least understood and least worked on problems, that how do you reduce the waste. So the first case of the sources, we can eliminate these emissions by transitioning to renewables. And in the second case, we have to figure out ways of reducing losses by efficiency, optimization, and by innovation. So I'll pause here for a minute, but just keep this idea of the ratios here involved. About 2/3 waste about 83% coming from fossil fuel sources, which need to go to renewables or transition to renewables. So when it comes to transitioning to renewables, the transition to renewables or to green energy is the key to tackling both climate change and creating sustainable economies. So this is according to World Economic Forum. But the transition requires actually a fundamental change, because you are going to disrupt literally hundreds of years of progress that has been made of generating all this energy, utilizing this power, using this power. So it's everything from drilling for oil to fueling your gas tank at the gas station. So this requires a fundamental change in business model across industries, because energy industries, as you saw, is not just transportation, it's industrial use, residential use, everything has to change. It also means that changes have to be done in the way that civic services are delivered by the government. A lot of the services that are delivered are either dependent on these energy sources or are even subsidized by the government. So some of these civic services have to change. And last but not the least, the consumer behavior has to change. In terms of, should we keep the engine running when we are sitting idle, or the engine idling when we are sitting at the traffic stop? Maybe not. But a fundamental change is also an opportunity, right? It's actually a breakthrough opportunity. I consider this a unique time in history where we have a chance to actually disrupt all businesses all at once, all of society all at once. So this is a really interesting time. It's going to be very challenging, but it's also a breakthrough opportunity, because we can utilize this opportunity to define new business models, which are going to be green economy business models. We can change how citizen to government engage. For example, instead of us going to a government agency to get our work done, how can it be made more efficient? How can we make it more digital, online, etc., right? And reduce the emissions per engagement with civic services. And last but not the least, we can actually drive consumer engagement. And energy has an equation to play in all of this. So these are not my words, but never waste a crisis, right? Even if it is a green one, right? So if we are facing a green crisis, so we should utilize it. So if this is a breakthrough opportunity, I think this is really key that we as information professionals understand that this is a unique opportunity for our domain or our area of study. Because information professionals are very uniquely positioned, because we understand the data to wisdom hierarchy. And this is very critical. I think this data to wisdom hierarchy is often missing. We were having Gary and I, we were having a chat earlier today about the impact of AI. And I think, in my humble opinion, the way AI is being rolled out across everything, we are probably optimizing on knowledge with AI, but I think we are definitely not being wise about AI. So that's another way to look at it. So as information professionals, right, we have this unique capability of understanding that everything has a price when it comes to ethics, right? How can we align our research to ethical standards? How can we actually define processes, right, which will help go from this data to wisdom hierarchy, data to information to knowledge to wisdom. And then information science is also very unique in the sense that it gives you a set of tools. A lot of disciplines give you a set of tools, right? Computer science also gives you a set of tools. But information science and library sciences, they give you a set of tools to help you collaborate across disciplines. And while at the same time maintaining the human aspect, right? So it's really important to understand that a lot of disciplines can be about data-driven solutions, but I believe only information professionals have that moral clarity to look for the ethical path to solving these challenges. Okay, this is a busy slide. Sorry about that. Okay, but for a second, you can humor me that above all else, we should show the data. So when we as information professionals deal with any problem or issue or project, right? We are typically looking at it from how can we utilize data to solve that problem. I like to use this data value chain methodology. This happens to be open source. You can actually check out the source here. But the critical part here to understand is that this gives you a roadmap of the type of skills that are required to do some of these data-based, data-driven solutioning to solving those challenges I put forward earlier. So some of the skills I've listed down, but the important item here to look at is that it is always about this entire interaction from right from the collection all the way to the impact of the solution, right? So, and I'm not going to read through this entire slide, but you can take a look at the type of skills which are required, ranging from project management to even AI. So when we look at this data value chain, the important criteria is that we also understand what is the value of the data. In the bottom of this diagram, you can see the value of the data increases from the raw data collection or production to the use. So the highest value is when your data-driven solution is having its impact. So we can have a separate session just to talk about the data value chain, but for now, I'll pass on. But the slides also I can share later if you guys want to take a look at it. So when it comes to a data-driven solution, right, we all have different approaches of dealing with it. We all come with different skill sets. We as information professionals have a variety of different skill sets. And I like to categorize the skill sets required to solve some of our most pressing problems into three categories: transferable skills, industry-oriented skills, and green economy skills. On the very left are your skills that we as information professionals often have while coming out of your school, undergrad, grad school. So these are some of the transferable skills that we can bring. It doesn't matter whether you are IS grad or LS grad, you probably have some of these skills. So right from metadata design to database management. This is just a sample list. But it's also important for us to really understand that just by having some of the core foundational transferable skills is not enough. We may often need industry-oriented skills as well as green economy skills. So I like to call it from books to batteries. So one of my clients is a battery cell manufacturer, and they were having some very interesting problems. And those problems are the same kind of issues that any LS student or professional may also recognize. because they wanted a way to, classify and categorize all the different kinds of batteries they want to manufacture. How do you categorize them? How do you classify them? How do you do faceted classification? Because they have to make very different products, very different product lines, and for each cell that they manufacture, they have to keep track of the data from that cell over its lifetime, from manufacturing, actually from raw materials, through the manufacturing process, to its first use case. So if it goes into a car, you have to still track how it is being used in the car, to end of life, and or even second life. So that's why I put this example as, so in their world, it is part of product lifecycle management. But even before it is a product, it needs to be defined. The product has to be actually built in a lab. So you have to have a lab or information management system. So these are some of the industry-oriented skills which I suggest that we as information professionals start thinking about, right? How do we leverage our transferable skills and knowledge that we bring from the academic world, get some industry-oriented skills, and utilize them to actually resolve some of these issues that we are facing in the world today. Another really good example is the enterprise asset management. Lots of large corporations, right? In my experience, for example, the major electric utilities, they have physical assets spread over a large geographic area, which have to be maintained, and those are critical assets, right? You don't want blackout in a hospital. You don't want the traffic lights to go out during a storm. So it's important to manage the assets across an enterprise. But fundamentally, conceptually, it is not much different from digital asset management, which we as information professionals may have learned in school. So this is another example where you can take some of our foundational skills and apply some of the industry-oriented knowledge and upskill and actually use them in industry. But the combination of transferable and industry-oriented skills are not enough for energy transition and for enabling a green economy. You also need some new skills, which even other industrial, I would say, typical technical professionals may not have. And these are the new domains and disciplines which are being built as we speak, which range from sustainable product design to sustainable IT to sustainable supply chain analysis. And the common thread through all of them is that you still need a data-driven approach. The example from going back to the cell and battery example, how do you actually design a cell which has the minimum environmental impact? To do that, you need to get data from the mining companies, right? Because the lithium has to be mined somewhere. So you look at, can we get the emissions data from the mining industry or your mining supplier? What happens to the product design so that it's easy for you to reuse and recycle at the end of the day? That's also, keeping track of a variety of different types of designs. So there is some very interesting aspects where you could potentially leverage your existing IS skills into green economy skills. Okay, so I wanted to take one more example, and this is the information career path. This is not my career path. I can talk about my career path as well later. But this is actually a sample position description that the US Department of Energy has released. And the reason they have released this is because the US as well as rest of the world really have a tremendous shortfall of skilled energy data analysts. We ourselves, in our startup, we are heavily dependent on doing energy data analysis. And so we understand this domain fairly well. But the key takeaways here are the skills and experience that they have listed. Obviously, you need to have some understanding of of organizing and analyzing energy data. But other than that, most of these skills are something that a typical IS or LS grad would know. How can you actually do statistical analysis, for example, data visualization, right? So the reason I'm putting this thing up on the screen is because I think it's important for all of us to think outside of the box in this case, right? What are some of these new career paths which can potentially, be a really fulfilling career, but at the same time help save the planet? And this energy data analyst is typically a really good example. And if you go online and look for open positions, you'll see a whole bunch. Later in my presentation, I've also listed about 18 million or new jobs will be added in the new economy, in the new green economy. So it's a tremendous opportunity for our discipline here to make a difference in the world. Any questions, comments before? Okay, so I've added some couple of more sample green economy career. So the first one is the sustainability data analyst. This is a really interesting one because this shows how much the world has changed in the last, I would say, 10 years or so. Because a lot of the sustainability discussions in corporate circles was earlier about, how do we make the corporates, look more sustainable, do a little more greenwashing. But in the last few years, in the last 10 years or so, there has been a conscious effort to actually look at doing regulatory reporting. A lot of the governments, initially the EU Corporate Sustainability Reporting Directive came out, and with that coming out, there are a whole bunch of other reporting initiatives have been launched globally. So a sustainability data analyst actually helps clients, major industrial, commercial clients in meeting some of these regulatory requirements. So this is one, if you are interested in making reports, or if you have an interest in even accounting, then this may be one interesting career. Second one is sustainable energy analyst. This is more research oriented. So for example, if you are interested in going through a lot of proposals or writing proposals, doing research documentation, analyzing what are the benefits, then this is a good, a really interesting role. The last one is for folks who are interested in IT. I personally was very interested in the IT and green IT area for a few years. I've done some work in this area, but sustainable IT or green IT analyst looks at the environmental impact of typical enterprise IT. And enterprise IT is a very significant consumer of resources and energy. So data center in some countries actually account for 10%, 20% of the energy use. So here I think in the US it's about 1 or 2%, but it's also of a tremendous value addition in the sense that as we increase the amount of data in the world, computation in the world, the amount of energy used in IT also really it becomes a challenge. So how can you do sustainability improvements by analyzing, the efficiency of IT equipment, optimizing IT equipment. So that's also another interesting career path. But green change is around the corner. So it's not just a talk anymore. There is some serious thought, serious money being spent in this area. And I think it behooves us as a discipline to really look at it, not just in terms of greenbacks here, but actually look at what impact it could have. So as investments move from the traditional industries towards green investment, I think it's a tremendous opportunity. Whether you want to go into a corporate career or entrepreneurship or academic career, I think keeping your green career options in your mind, I think is really important. And as I said earlier, right, remember that it is, we vote with our talent. So, there is such a dearth of good, skilled talent in the world. It is important that we invest our own talent, make the right choices, which will be fulfilling for us, both financially as well as, I think, from a moral standpoint. As I said earlier, about 18 million jobs are net gain of 18 million jobs by 2030 is estimated. And all of these are actual numbers of money being invested in the green economy. Actually, while doing the research, I didn't realize that EU is now in an arms race in terms of, with the US in terms of putting out funding and investment in green technologies. So this is something to look out for. So that is the end of my presentation, but obviously if you have any questions for the presentation, you can ask me. On the presentation, you can ask me. But if you have any questions, comments, or if you want to know anything about my career path or something like that, obviously. And if there are questions online, you can ask as well. Thank you. Yes.
Are you able to say a few words about your company that you were
Yes.
Working with now?
Yes, sure. So I'll give a little bit of background here. The context is I spent most of my time after sales in consulting. Actually, I was a campus hire from UNC. I was in IT consulting, working most of, I would say, about 7-8 years for energy utilities, and I was doing enterprise architecture, systems analysis, design, doing IT evaluations, things like that. So I did it for some time, and in 2020 I was one of the many millions who again voted by changing a career. So in late 2020 I was part of the Great Resignation at that time, and one of the key triggers for that was in 2019, I and a few of my friends in consulting, we had met my other co-founder Chris, who is here, and we happened upon a really interesting breakthrough technology which can potentially change how energy is used. I'm talking about the electrical grid and electrical power consumption, energy efficiency, as well as fundamentally alter how we actually utilize electricity in industrial commercial environments. So in late 2020, a bunch of us quit consulting jobs, and decided to form a startup. It's called Optimized Sciences, and we are trying to bring this breakthrough innovation to the market. Doing hardware during a pandemic is really hard. There's a reason. My favorite joke these days is, doing hardware is really hard. It didn't help that, there was global supply chain issues, pandemic, war, but we've managed to go through them, lots of ups and downs. But at the end of the day, we are trying to really alter how we can actually make energy efficiency better, improve the resiliency of our grid, and really bring some much needed, I would say, a focus on what's the best way to utilize the talent that we all have. So that includes not just our small team, but across our partners and rest of the industry. So a little bit of a long spiel or a preamble, but thanks for the question. Any other question? Yeah.
I was particularly interested in the, I appreciated the talk, I enjoyed it. I was particularly interested in the data life cycle thing that you were talking about. And I was curious, in your opinion, what the overall quality of the data that's being collected and used. And there's so many different frameworks and stuff, and it's a lot to wrap your head around, and I'm curious sort of what you see that early stages of this process.
Okay, so that's a good question. Data quality is always a challenge, right? When it comes to, particularly to energy data, I think the challenges are much more than a lot of the other traditional, data. And the reason behind this is, and this also came up during our lunch conversation, is that some of the data sources themselves are really unreliable. So, one very interesting example which you can see for yourself is that when you go home, turn on the microwave, and if you're able to read your meter data, if your microwave says 1,000 watts, I can bet you your meter is going to report more. Because there's one of two things. Either the meter is wrong or the microwave is wrong, right? Both cases are bad. So that gives you an idea of the quality of data issues. The other problem which you will face with data quality is the resolution of the data. To give you an idea, I would say majority of the large installed cities or installed bases of meters across the world, they are now smart digital meters, right? So you would think that these are really good devices and able to get a lot of data. But those devices are typically reporting data once every 15 minutes. But when you are consuming electricity, you are running your microwave for 5 minutes. When someone is charging their EV or starting a motor or starting something, they are not starting once every 15 minutes. When a device starts or something starts, right, it consumes power very differently in the initial phases, during active operation and during shutdown. Right? But this meters which you have installed, they are collecting data only once every 15 minutes. So as an information professional, right, you have to understand how is the device actually using energy, how are the people using energy, and what is actually being reported to me. And there is a significant disconnect there. And that impacts the quality of the data, therefore it impacts the analysis and the output. So it's an enormous challenge. I have personally spoken to many utilities, both here in the US and in the rest of the world, and it is a constant problem. The other issue which is very unique to at least the electric utility industry is that electricity for the most part is the most ephemeral product that humanity has ever made. The reason is, once the electron is made, whether at a hydropower station or coal or whatever, right, it is surviving only a fraction of a second. You know, it is generated and you consume it. For the most part, the amount of storage in the world is not sufficient to really make a dent. So how do you deal? You have a demand and supply problem where you really don't have enough data about how demand and supply is going. At the same time, you have to meet the demand instantaneously. So the whole grid, that's why it's the most dynamic and the most complex invention that man has ever made. So sorry, so that gives you an idea of the complexities involved, right? So, and that's why data quality is a constant challenge. But a challenge is an opportunity.
Yeah.
Yeah. Yes.
I have one quick question. We met briefly last semester. I think Gary introduced us
Oh,
over
okay.
Zoom. Yeah.
Yes, yes, I remember.
And
meeting
you
online.
talked about one of the biggest things you wish you had learned more about sales and in your education was storytelling. You had
Yes.
learned how important it is now with your work. So can you talk a bit more about that?
Yes, yes, that's a very good question. I wish I was better at storytelling. As you can see, I should have taken that course. But you know, I think at the end, you know, whenever we are giving a point of view, or making a presentation, or writing anything, right, it has to be relatable. And that's why I think telling a story with a proper storyline is so critical. If you are making a business presentation, or if you are, you know, making a speech, it doesn't matter. Unless it is relatable, it will not have an impact. And I think all really great marketing people are great storytellers. Steve Jobs was an amazing storyteller. I think we all need to become better storytellers, right? I think our ancestors were far better than we are. I think we have become too accustomed to, you know, AI-enabled chat GPT storytelling mode, but I think we need to be better at it. And I think it will be of a tremendous impact if storytelling was included as a part of every curriculum, in every discipline. Because we all have to tell stories. Whether you're doing biomedical research or you're, you know, working on metalworking, everything has to tell a story. Thank you for that question. Yeah.
Hi, so I actually am not a still student. I'm also a consultant working in the sustainability space right now. So closer to like the sustainability data analyst. I work with clients to help put together things for these frameworks and the reporting and everything. So I know one thing that we think a lot about with our clients is kind of goes back to about data quality, data integrity, you know, sort of building from for your emissions reporting, like from the ground up to, you know, get to your storytelling sort of at the reporting level. And kind of, I was curious what your view is sort of on when we have these frameworks, but we know we have the challenge of data quality. Is it better, you know, is it a better view to set these standards, these like reporting standards stricter, and to, you know, say, okay, now we need some innovation in order to bring that data quality up to like where it can be reported and it's comparable, or is it better to sort of, you know, bring these standards down to where you're getting to like a level of data quality that you're comfortable comparing to like a wider audience?
Yeah, it's a very interesting question. So with one of our current clients, we have been trying to address some of their sustainability reporting requirements, and we were quite shocked to find that even some of the reporting standards really don't. They are more or less broad guidelines. They don't really give you, and you would have seen that yourself, right? So it's kind of really difficult when it is a regulatory report that you have to send, but you don't know how it will be evaluated. There's no objective criteria, and like some of the EU reporting standards, just write something. That doesn't help. But I understand why they did it. The reason is they want first to make people comfortable with the notion that they have to collect this data and report. Start with something, because this, the more I talk to folks about the issues, right, from the guys who actually consume some of this reporting, regulatory reporting, they seem to say that, we are all in this discovery phase right now. We are all trying to find out what works. And at that point of time, it's better to keep it loose. Let's figure out how things will work out. And then once everyone is comfortable with the fact that they have to at least start collecting data and report, then we can make it more stricter. But it is becoming stricter. For example, again taking the battery example, there is a global initiative called the Battery Passport. So for every, that picture was of a cell. So the way I give a disclaimer is I am actually not an electrochemist. So when I interchangeably use a battery and a cell, don't blame me. But for every battery sold or every cell sold in the EU wants to get something like a birth certificate, which will have all the attributes of that particular individual cell or that individual battery when it was built. And that's really important, because that is the first time where you can introduce traceability right from manufacturing all the way through the end of life or second use or end of life. So there are some initiatives which will, I think, improve the reporting requirements, like this battery passport, but it's still early days, which also means that we have a tremendous opportunity. So this is our chance. So, thank you very much. Any others? Any question online? Okay. If we are good, then thank you so much for this opportunity, and I really liked this interaction. So thank you for inviting me. Thank you.